Morning everyone and everyone online. It's great to be in a room with people after 2 years of not holding a real AGM, so it's nice to be here and thanks everyone for turning up today. As you know, my name is James Walker. I'm the Executive Chair of BluGlass. Welcome to our 2022 Annual General Meeting. It's after 11 o'clock. We have a quorum, so the meeting is now officially open. Today's meeting is a hybrid meeting, which means there are people online and people in the room. This allows shareholders to vote and proxies to attend the meeting virtually. So I'm not sure how many people we have online, but I assume we have some people online today, which is great. There you go, great. Because it's a hybrid meeting, a bit of compliance, a bit of housekeeping on how to vote. So to vote at this meeting, you need to have registered your shareholding with Atomic. If you haven't already done so, you can follow the instructions on the screen to register and log in and enable you to vote at this meeting. Questions can be submitted at any time. To ask a question, press on the Q&A icon. This will open a new screen. At the bottom of that screen, there is a section for you to type your question. Please start your question by typing your shareholder SRN or HIN number. This will allow the moderator to identify you as a shareholder. And if you'd like to ask your questions verbally, type in your SRN or HIN and then say, "I would like to speak." Once you have finished typing, please hit enter on your keyboard to send. Please note that while you can submit questions from now on, I will not address them until the relevant time in the meeting. Kindly start your question with the agenda item number to which it relates. Please also note that your questions may be moderated, or if we receive multiple questions on one topic, amalgamated together. Due to time constraints, we may run out of time to answer all your questions. However, we will endeavour to answer as many of these as we can. Voting today will be conducted by way of a poll on all items of business. To provide you with enough time to vote, I now declare voting open on all items and business. You can submit your votes at any time, and I'll give you a warning before I move on to close the voting on each item. I trust you allow us some latitude, but third year in, we should get the technology right, I would hope, for a meeting like this. Here with us today at 383 Kent Street, Sydney, are the non-executive directors, sitting over there on my right, Steve Wilkes, Jean-Michel Pellopat and Vivek Rayo. Also attending is President Jim Haden, Chief Technology Officer Ian Mann, sitting at the front, our new CFO Rob Ambrilio, and our Company Secretary Emmanuel Correa. So we actually fill up most of the room. So thanks for coming, BluGlass. This morning I'll take you through our FY22 highlights, an overview of our financial performance and an outlook for the year ahead. I'll then hand over to Jim for an operational update on our laser diode progress, Silicon Valley fab integration and our product roadmap going forward. The board and Jim will then answer shareholder questions before commencing the formal part of the business. So let's get into it. All right, so 2022 highlights. Last financial year was a significant year for BluGlass. We delivered on several key commercial and technical milestones which have set the business up for the long-term success. We enter FY23 in a stronger position than ever before, well on our way to becoming a leading commercial manufacturer of gallium nitride laser diodes. To re-emphasise that, in March this year we acquired a fab in California that already has laser diode production facility and manufacturing capabilities. We also hired the team, which was critical in getting that fab operational as quick as we can. The acquisition of that fab has many advantages for the company going forward, and at a fraction of the cost if we were to build one ourselves. So I think most of you will know our strategy was always to build a fab, but once we had a product in the market and had some commercial traction, through Jim's network we actually came across one much earlier than we thought and at a significant lower price, and we thought we had to jump on that at the time, and we did that. And once again, we did that with your support in terms of the fundraising, so thank you for that. Our California fab team are now operational and doing several of our key process steps. We continue to convert the manufacturing process across to GaN. Our team is bringing core production processes in-house so we can reduce our supply chain complexity and also reducing our reliance on our contract manufacturers. During the year, we made significant improvements on the performance of our laser diodes, sold alpha products for commercial evaluation, and we continue with high levels of interest from our products from customers. There is definitely a significant unmet demand for our products once we launch them. We're executing on a clear technology and commercialisation roadmap to transition the company from a traditional R&D company, which we have been, to a commercial manufacturer of products, particularly in the laser diode space. During FY22, we significantly enhanced the technical expertise of our leadership team. I think most of you will know that Jim joined us in September last year. Jean Mattel joined the board in May last year as well. We're attracting highly experienced GaN laser diode experienced team in the manufacturing capability at our fab in California. Jim will talk more about the calibre of the team in his presentation. In recognition of the progress that we've made and through our connections in the industry in the US, BluGlass was invited to join the world's leading gallium nitride lighting and electronics consortium. This invite-only collaboration between industry leaders and the preeminent University of California, Santa Barbara GaN researchers will be instrumental in delivering our future products. All right, let's talk about our finances. So I've been told to highlight there was a typo in this slide. Cash was actually up 28%, not down 28%. So anyone who's looking at the ASX announcement that came out before today, apologies for that. All right, let's talk about our performance. So FY22, we had a financial loss of $9.3 million, up from the loss of last year of 6.3. A lot of that had to do with obviously running contract manufacturers and getting our new fab online and actually fast-tracking the development of our laser diode products. So more consumables were spent in FY22 than FY23. Revenue was about the same at about 4.3 million over both years. What is offset by that, which will be reflected in the FY23 numbers, is the more work we did on product development, the more work we spent on consumables means that our R&D refund, which we will receive in this quarter in FY23, will be closer to $4 million as compared to the 3.5 that we received last year. So our R&D refund will be up. So there's some extra cash flow coming into the FY23. As you may have read, the US government has passed legislation called the CHIPS Act, which is to help build a reliant semiconductor industry in the US. That's a 75 billion Australian dollars investment to help rebuild the semiconductor industry in the US. You may have noticed the Australian government did the same thing, but that was 1.5 billion is the recommendation from the think tank. It's actually not government policy yet, but countries are starting to realise that we can't just rely on Taiwan for semiconductor products, which are really the basis of everything that we see today. We are investigating if we're eligible with our US-based fab, if we are eligible for any access to the funding from the US bill. And we'll keep you updated on that as we go. The other part to notice on, obviously, for our results and our cash is we've got some options that are just in the money, I would say, at 3 cents that are due to expire in November. We're very supportive and recommend to our shareholders that if you can take up your options and exercise those, that would definitely help the company with its runway for FY23. You may have noticed I exercised my options a couple of weeks ago, so I recommend everyone else can do the same. So let's talk about our patents. So patents are critical to BluGlass's future in terms of protecting our IP and also adding value through the shareholders through having strong IP that we can then rely on to build a sustainable business. In FY22 was another good year in terms of patent development, where another 7 patents were granted in our key markets, which now means we have 91 internationally granted patents around the world. We will continue that strategy, particularly around the laser diode space in FY23. Our RPCVD technology, as most of you will know, provides BluGlass with a truly unique point of difference to our competitors and the potential to create higher value, brighter and better performing laser diodes in the future. While our initial products will be MOCVD, our future products are based on commercialising the RPCVD technology, which has been the basis of BluGlass over the last 15 years. All right, so let's talk about where we are. So BluGlass is executing on our plans to develop and commercialise products in the laser diode space. We are using our technology in our 3 facilities in Silverwater and 2 in the US to build and launch laser diode products. We have customers that are waiting for those products, and the markets are large enough, as Jim will talk to build a sustainable business with the launch of those products. We are continuing to transition the business from a commercial laser diode manufacturer producing high-quality laser products. That will continue. Our initial product launches will be in the violet and blue wavelengths, including 405, 420 and 450 nanometers. They are the products we've been talking about for the last 6 to 12 months. Critically, our own fab provides us with greater operational control and simplicity. It means we can do more turns cheaper and to get more products out to the market quicker. This has been fundamental to where we go as a company going forward. It removes our reliance on contract manufacturers, and Jim will talk to what that has meant to us over the last 12 months. It means we can turn products around quicker and develop products and get products out to market. More importantly, it means we can increase our manufacturing capability. So with the fab coming online, we are able to produce products worth $160 million US a year. Not saying we're going to sell $160 million worth of product in the first year, but we have the capacity once Fremont is up and running to produce that amount of product. That's clearly fundamental to how we go forward. To help with that, we have changed the team in the last 12 months particularly. We are attracting experienced laser dioide experts to lead the development and optimization and commercialization of our products. With the fab in California, we've been able to hire people that we've been completely unable to hire before that. We were trying to get, as an example, trying to get a laser diode science in the US on the East Coast for about a year, completely unsuccessful in attracting that talent. But with the fab in California, Jim placed someone in about 6 weeks' time. Great example of where the industry skills are and how that's going to help us going forward. As we've talked about in an earlier announcement, we have sold our first alpha version product to a customer for testing. That testing is going on, but it does prove that not only do we have the right technical team in place, we also have the right commercial people in place who know who the customers are. And you will see that continue as we go throughout FY23. Longer term, we have a significant opportunity to leverage our RPCVD technology to offer brighter, more efficient and better performing GaN laser diodes in lots of varieties of colours and wavelengths. Part of our longer term plan, our focus, as everyone knows, is to get first versions out of the MOCVD 405, 420 and 450 into the market, but those other products will come after that. So on behalf of the board, I'd like to thank all our shareholders for their support over the last 12 months. We're disappointed we did not get a product out this year, but in saying that, I've never felt more confident that we've got the right team in place with the right resources and the right capabilities to actually deliver on that. So I think FY23 and beyond is going to be, we're in a great position to exercise on that this year. Changing tack slightly, and we've touched on it slightly before, semiconductors are a critical industry going forward. In our own federal election, both parties talked about not having reliance on Taiwan, who produce most of the world's chips, and actually start to develop an industry here. New South Wales government is also talking about developing a semiconductor industry here. We are part of that process. I mean, in reality, we are the only vertically integrated manufacturer and semiconductor manufacturer in Australia today. So we are playing a role in that, and you can see that going forward. Quite hopeful that the policy on the Moonshot initiative announced 2 weeks ago, that will turn into government policy and we can play a role in that. So that's most of what I wanted to talk about today. The other part, of course, is, aside from thanking our shareholders, is to thank the team. The team is a new team than what we were here 12 months ago. I think we have the right team in place to actually execute on our strategy with the right skills and experiences. So I'm looking forward to what this year brings. And with that, I will hand over to Jim.
Thank you, James. For those of you that don't know me, I'm Jim Haden, president of BluGlass, and I've spent much of 3 decades working in the laser industry. I've worked at companies like Spectre Diode Labs, which merged with JDS Uniphase, stayed at JDS Uniphase, went to Coherent, and then I went from Coherent to Enlight. And from Enlight did consulting and worked at a company called Sora Laser Diode, which became KSLD. They were purchased by Kyocera. And most recently with BluGlass. And during this time, I've faced a lot of the problems that we are facing here. some in different material systems, some in similar material systems. And that experience with this great team of BluGlass, we're systematically going through and solving the problems. With that, James talked about our patents. Patents are a really important part of protecting what we have at BluGlass, but another important part is the intellectual property that we create within the walls of our building. We don't say everything that we do, and we can't say everything to do as we transition to a commercial company from a research company. So you may be used to really a lot of detail in the technology, but we're going to cover the high levels of that technology, not the details. So the year in review. In the August timeframe, we demonstrated our first RPCVD active as grown dual N-wave laser. This was an important milestone for the company because what it does with the junction, the N-wave part of that is it allows us to decrease the resistivity of the laser and decrease the loss. And what that does is it leads to more efficient lasers with better thermal performance, and we use the RPCVD technology that the company has been developing in order to do that. Now in September, that's when I joined the company, and so I started evaluating the processes we had, and I knew from my experience I just told you about that the best way for us to move forward as a company to be most competitive would be to have a wafer fab. And those, it's not like there's wafer fabs that are coming on the market every day. So I actually knew somebody that was going to be closing down a fab, and she introduced me to the CEO of the company, and I was able to make some inroads. And with your support, we were able to acquire that operational facility in April of this year. And that has been instrumental, as James mentioned, and I'll talk about that as we move through this presentation, how that has made us more agile and led to our some significant findings that are guiding our product development. Now with that, in the same month, we were able to, by mid-year, we had the best lasers we've ever had. This was not through our fab, but with our CMs. And that performance that we achieved from those lasers helped us to gain traction at 2 trade shows, and the one in April was a World of Photonics, and we generated significant customer interest in showing both the 405 and 420 nanometer lasers, and that led in later to shipping our first fully packaged alpha products, as James mentioned, in June of 22. Now, after that, when we had the fab, James mentioned that we were able to accelerate hiring. But when we got the fab, we hired a team that had been running that same fab, a veteran team of technicians, and they brought a lot of experience. And it also came with metrics that we didn't have access to prior to the acquisition. And so what we did at that point is we were able to look at what our CMs were doing, and we were able to feed that information back in our product. I'll talk more about that. But one thing that happened is we talked about this. I started getting calls from other colleagues. One of them was Professor Steve Dunbar's at UCSB. He and I go way back. So one of the things he said is, I've got a great grad student. He was an engineer at Cree, and he's going to be graduating soon. You got a spot? And we said, absolutely, we've been looking for someone. And he was the best candidate that we had. In that same call, Steve invited us to become part of the UCSB consortium. It's a prestigious group, and it's an invite-only type of situation. So it was really nice to get that invitation and a vote of confidence from my colleague. And so then by I'd say the mid-summer, we got our permitting, and in September this fab is online and already contributing, and I'll talk more about how. So previously you've heard us talk about 4 of the key ingredients required to make reliable laser diodes. First, you have to have low loss, high gain epi. You have to have low resistance and metals and ohmic contacts. And then we have to have pristine facets. In the facets, the the face of the diode that allows the light in and out. And so then there's thermal mechanical bonds that are also required. They interact with the diodes. And all of these things interact together to make a reliable diode. We early in the fiscal year, we initiated a project to focus on these 4 key areas. And what we did is we tried to put in metrics to measure how each of these looked in both short loops and as we were moving through with our CMs. And we wanted to make that kind of, see if we could make improvements. And what we did is we were making incremental improvements, and like I said, it led to the nice diodes that we were able to show and get traction. But the good thing is since that time, we've looked at the performance of those lasers. We've also looked at inline metrics, and we're taking those metrics in all 4 of these key areas, and we're feeding it back into our development since that time. And now with our fab coming online, we have the capacity to bring all those together in one place. We've got 2 new epi designs that we've launched, and this was using the team in Silverwater, looking at their metrics that we could do that are fast turn. You don't have to make a full laser to get these. And they've done some wonderful improvements, both with the modeling and then with growing and testing. And those new designs are highly promising. We've seen the best light output and the lowest voltage that we've had to date. Now what happens is you get more light at the same current and less voltage. That means less waste heat. Less waste heat means a cooler laser. A cool laser runs longer. Same thing with our low resistance metal contacts. We basically were able to decrease the resistivity of our contacts, and also leading to the thermal mechanical bonds, we had very nice adhesion of that. And so those bonds and the metal put together, again, help you to run cooler. Now on the facets, what you want to have is you want to have nice, pristine facets where you don't scatter light. One facet you have highly reflective. The other facet you have really low reflectivity, so light comes out in one direction. Now we've improved, we worked with our contract manufacturers both on how to do a process called scribe and break after you thin the semiconductor down. And we've made improvements there on getting a nicer, pristine facet. And then what we do is we work with another CM to do the coatings on there. And we've made progress in both of those areas. And we're also looking at moving those later into house. So vertically integrating, both James and I have already talked about this, but I want to go in a little more detail of what's happening with our the vertically integrating our wafer fab. The first thing is that James talked about, yes, we have a lot more capacity. This capacity will enable us to grow as we're ramping, and the nice thing is it matches our it really closely matches the fab in Silverwater and the amount of epitaxy that we think that we could put out in a year, approximately 10,000 wafers. And this will get us about 4-fold the revenue that we were projecting to go with our CMs. Because our CMs would allow us limited capacity because they had other customers and so forth. Another thing that actually is very key is that we, with our own team, are turning around the information much faster. CMs are great at doing the same thing all the time, but they're not as great as doing development work. And so we're able to do development work much more quickly and get faster turns. And this basically has allowed us in a very short time to make progress in our fab, and we're getting more and more confidence in that. This, we already talked a little bit about this, but this is an opportunity that we went to, came to you, and I'd like to thank you again, our shareholders, for the $2.5 million that we got. But to do this from a brownfield or a greenfield fab would have been approximately $40 million and perhaps even more to build this today. And with the way the inflation is in the economy, it'd probably be much more than the $40 million. But then to note, as you know, any building is fine, but we had, as I mentioned, we had an expert team that came with it of technicians, and then we were able to attract talent that we just didn't have access to before this, having a fab in Silicon Valley. We found an excellent director who had been working at another GaN company, And so he brought a significant GaN processing experience in addition to the ability to run and put an efficient organization together. And then, as I mentioned, my colleague Steve Dunbar's introduced us to Dr. Ryan Anderson, who's just been a godsend to us. He's really helping the team and bringing a lot of good innovation to us. So this fab is helping and contributing already. We've received all of the regulatory permits that were required to do the wet, dry, toxic processing that we have to do. We didn't receive this till mid-July. We were doing what we could beforehand, what was allowed by regulations, but they gave us the green light in mid-July. And then just to be a testament of how far that team has gone, in a mere 6 weeks or so later, we started our first runs of process, the laser process instead of short loop. And the Silverwater team sent a bunch of the newer EPI designs to our fab, and now we're putting some of those key ingredients, the 4 key ingredients together, working with some CMs still, but taking some of the work that were previously done only outside. So we are already making improvements. And another way that the team is improving is, as I mentioned, we have been working with our CMs, and we have better metrics in some cases than they do. And so we've been trying to feed some improvements back to them. But what we're finding is we're accelerating that progress in our fab. And that is what we're seeing when we're looking at these different metrics, and one of them is optical measurements, and just basically looking at the lasers under high magnification scopes. We're finding that our workmanship is exceeding that of what we're finding in the fabs, the CMs. And what that means, when you have a high level of workmanship, you basically decrease defects, and defects basically equal failure in lasers. So the fewer defects, the better yield and the better performance you get long term. Our Fremont facility is coming online. This is just showing you some of the pictures of that. This person, you can't really tell if you meet him on the street, but that is our director of operations in the fab, Martin Aguilera. And just showing some of the equipment, outside view, nice sunny day in California. Some of our photolith equipment in the rooms that are more yellow, and then just some optical scopes and other inspection equipment. And in the far back, you can't tell, but there's the facet coders that we will be using later to bring that technology in-house as well. Our alpha shipments. We shipped our first alphas to our customers. They're 405 and 420 nanometer products. And it's so that they could start to integrate into their product and their designs. And many of the customers that we will engage with early will be in new product developments. And that affords us the opportunity to ship products that are alpha and beta and so forth before we have high reliability products. And you'll look at, when we look at our verticals, we see that there are different requirements in each of our verticals for how long a laser needs to live to address those. So what we're trying to do is look at how to address those as we get better and better and improve our reliability. But anyway, for those of you who don't know, an alpha product is basically an advanced prototype. We already know it has form, fit, function that customers need. But now we have to say, does it have all of the function, and can they put it into their products and make it work? And so it's a valuable tool. We already talked about how we can collect metrics in line while we're processing wafer. We also collect things when we do downstream packaging with our CMs and so forth. We get feedback during that process, but having customer feedback in addition to that is extremely valuable to us because it's a real world application. So we also are working with several customers to understand what they need in their initial trials, and we're engaged at that level as well. I talked a little bit about the consortium, a little bit more here. It's the University of California, Santa Barbara. It's Solid State Lighting and Energy Electronics Center. It's a mouthful. Basically what it is, it's a consortium of companies that come together, and they invest in and work with the students and faculty at UCSB. And so what we have done is we've set out a program for what we call, even more advanced products that we believe will be a really good market for us, especially earmarking toward higher performance products in the quantum area. And working with Dr. Dunbars and Dr. Nakamura, who's the Nobel laureate who actually invented the gallium nitride laser, is just an extreme privilege to us. And so we've already been down, we visited. Ryan graduated working with both Shuji and Steve, and so he's very familiar with them. And we've already launched that program, and we're working. It gives us access not only to their facilities and to Shuji and Steve, but we have access to postdocs and the people that they're getting ready to get their PhDs, which were they had a lot of questions for me when I was down there, and hopefully interest in joining BluGlass in the future. Basically, this is a testament. Both what we did is we talked about our RPCVD technology to them, and they're very interested in seeing how our technology and their technology coming together could advance gallium nitride products even further. Now to the market opportunities. So first off, why GaN? What are the things that are attractive in the market to GaN? Now, one is that, as you see here, there are a bunch of different metals in metal industrial processing, and this shows you relative to infrared how the absorption of blue is and other visible wavelengths. And you can see it ranges from 1.5 times to 66 times more absorption in these metals, which means when you have higher absorption, combined with the shorter wavelength, it gives you tighter beam focus and improved operational efficiencies because you don't have to put as much power in to get the work done. So what it does with those two things come together, it leads to precision manufacturing processes. And you could basically increase your processing time. You could decrease the spot size, making micro manipulations of the material available, but things like with the better absorption also helps you to have a more controlled process because you don't have all the excess heat. There's something happens when metal starts to melt, the properties change, and you could get some runaway effects that cause splattering and stuff like that. With the higher power IR, you don't get those processes problems. So you have basically cleaner and faster material processing with blue and violet. Target markets by application. Basically, we saw a $25 billion laser market by 2025. Of that, 2.5 billion is the global GaN market. Our serviceable market is about 735. That basically means with the products that we have in our roadmap right now, that gives us a market of US 735 million by 2025. Now in these, our markets that we're looking at is there's 240 million in the industrial market, 80 million in the scientific, 60 million in the biotech, and I'll talk more of those. Those are our three verticals that are quite interesting. That leaves about 52%, there's 48% left in the other markets that, we're not saying we're not going to do anything in those markets, but right now that's not where our key focus is. So the challenges and what do we bring? There's a lot of words on this chart. I'm not going to go through all of them. So I'm going to sort of say, why would, when there's big players out there, why would anybody want to use a small startup like BluGlass? And the answer to that is fairly simple and not dissimilar to some of the other companies I was at. There's basically two types of models out there. There's high volume, low mix, and that's where a couple of our major competitors are. And then there's sort of low to medium volumes, high mix. And high mix means that you have different product SKUs. It doesn't mean that everything has to be done a different way. You actually don't want to do that. But what you want to do is provide as many different types of products to the market as you can. Those two mixes don't work well, and our big competitors really are going after the high volume, low mix, and they're driving down the ASPs. we think with average selling price, sorry. So we believe that with the, similar to companies like Coherent and Enlight and Lumentum, we will have a broader mix, medium volume, and we'll have what we believe are going to be better ASPs. And we're going to be able to meet form factors that our big guys don't want to do. And oftentimes some of the wavelengths, because we will be able to address wavelengths that the other guys just don't want to. Right now, any market to us is a big market, but those are some pretty big numbers. And so if we look at the industrial segment, 240 million, that's a really nice segment. It's basically, this is where we look at the 450 and the 405. The key applications here are industrial welding, additive manufacturing, treatment and finishes of materials. There's heat cladding, where you harden the metals and so forth. Those are all things. Some of the key customers that we might focus on there are like IPG, Nuburo, Enlight, Formlabs. Those are a few of the key customers that we will target in those areas. The next one, $80 million market, is smaller, but this is an interesting market for a few reasons. One, it's the scientific and sort of focus on quantum is a little more, it's a newer industry. The industrial industry is very mature and requires a very mature product to get into it. So it's not, the industrial market is not the best launch market for us, but it's a good market for us to keep our, our finger on the pulse of and get into new product designs, but maybe not take over some of the existing ones. But quantum sensing, quantum computing, and even some laser pumping of what we call diode pump solid state. Those are areas where there's not as much competition, and they're basically newer processes that our customers are looking at, and they're a lot more apt to want to work with a hungry group of people that say, yes, we can help you solve your problem. So what we're looking at is not just our customer, but what does their customer need, and how can we help solve that chain of problems that they have. Some key customers that we're talking to there and targeting are Toptica, Bosch, Coherent, huge laser company interested in what we're doing, M Squared, and Laser Quantum. The next market also is interesting. Biotech, this is a very interesting market for several reasons. It's not as big, but in the biotech industry, oftentimes the lasers aren't used 24/7 like they are in industrial. So it's a different level of reliability, and there's a different level of performance. And there are things like flow cytometry that can be used to look at what type of cancer cell a person may have. So they're very important type of things. But these sensing applications don't take a lot of use for a laser. So the same thing with optical coherence tomography, where you're actually doing some mapping of subsurface tissues. Thank you. But those are some very nice applications for us, and there's interest in the market of what we can do. Again, some key customers there are Modulite, BioLase, and Innovative Photonic Solutions. So our strategy and roadmap. So bringing FREMONT online, talked through this quite a bit. I'll go through some of these highlights, but won't talk to every bullet point on here. Basically, we acquired the fab in April, and we went through a first level of conversion. During the period of time, we actually cohabitated with the company that was selling the equipment to us, and the first hires previously worked for. And then, so there's basically cleanup going on. They had to clean up to move out. We wanted to make sure it was cleaned up before we move in, and they were happy to have us cohabitate and critique, as it were, and help clean the place up. And so the stage one conversion with the expert team, we started converting over to GaN because they were processing a different type of semiconductor. It's called indium phosphide. And so we were able to do cleanup with them and do conversion and make sure the equipment was all working the way we needed it to. And then when we got the permits in July, we hit the ground just running, and that was a great milestone. The fab, I don't want to understate it, or and probably can't overstate it, but this team, with their maturity, they had been working with all of the local and state regulators, and that could be really, really difficult. And we're very appreciative of the company that sold us the equipment, but our team cleaned that place up, and it looks so much better. The inspectors were just like, we love you guys, and they were very, and they're like, they were doing as much as they could. We want to get you started. So the day that the other company got their work done, they said, you got the green light to go, you've got everything in place, and start doing it, and tell us how it's going. And so that was really nice. And so we were able then in a few short weeks to bring up the P-side processing and bring that all in-house. We've got the process flows, and in that amount of time, we've already started another lot. We shipped the first lot on to our CM for the downstream processing. But as we note in these other points, we're going to bring in some of those downstream processing in-house. And this team is chomping at the bit, and they're really wanting to start moving on those more quickly if they can. So they are striving to allow us to get faster turns, process more material, and accelerate our plan to bring the CMs in, which we put a plan together where we would exit the CMs, exit our dependency on CMs by the end of this fiscal year. So we wouldn't have to do any of our production when we moved there. So this shows sort of our technology and commercialization roadmaps. And as we talked about blue laser diode, blue and violet, we've been working on those, and we want to move through the final stages of our alpha and have as I talked about, we had our performance that we generated interest in the market, but now we've taken and we've had these short loops where we've taken these 4 areas of epitaxy, metals, facets, and bonds, and those are all now coming together in our fab. And so we're really excited to see those come through and through the line and get processed to see where we are as we come to the basically, the beta is where you're stopping. As I mentioned, in alpha, you take design feedback and you iterate the designs. In beta, what you do is you freeze the design and then you validate the reliability of that design. And we've been doing some reliability testing during alpha. That's how we know that we could get to a place for where we're able to get better processing capability and better reliability of the diodes. And so in parallel to that, we've been setting up our ability to test the diodes in our Nashua facility. And so as that's coming online and we're bringing our fab here online, we want to bring that all together and show the reliability as we go through the beta in this, I guess it would be Q4 calendar year, Q2 fiscal year. And so basically our beta products and our commercial plans are there in sort of the, what would you call that color? Magenta or and cyan, I think. And then we're trying, we have what we call accelerated lifetime testing. Often you have something called HAST, highly accelerated. We're not set up yet to do HAST, but we want to do some accelerated life tests to show what we have and how our lasers will perform. And another thing to note with our increased capacity, our green, we've already launched with our RPCVD green. We're excited to move more toward the green, and we've got EPI using RPCVD in our fab now. So, this is just showing the roadmap in a different way. The far left is what we demonstrated earlier. In the middle, those are all the violet, blue, and now green that are in development. And on the right, that's where we've got higher powers at different wavelengths. And we'll find some more products that are coming into the right in the future as we work more with UCSB and our internal programs as well. So our outlook. Basically, we fast-tracked the company goals with this acquisition. And I know, as James mentioned, there's frustration that we don't already have a reliable laser in the market, but this fab acquisition is going to give us the turns that we need to be in much better control of our own destiny. It was a matchless opportunity, and thank you again for the investments that you've all put in to allow us to do that. It's we've got the improvements through the mid-year with the interest that we got in both in the US and in Europe from showing our products. And that has been combined, the feedback that we've gotten there has been combined with the metrics that we've gotten with our internal metrics, and then also with our downstream packaging CMs. They've given us a lot of valuable feedback. All of that is coming together now so we can deliver on this roadmap and put these better lasers in the market and become one of the main players in the GaN. And so they're large, growing markets, and that's where we believe we're well positioned to play. And I would love to answer questions now, but I think I will, before I do that, hand the floor back to James.